Use substitution to find the integral of cos cubed x sine x with respect to x. Now, I know I've spoken in previous videos about kind of reducing powers. For these integrals that follow, I'm more testing, can you actually use a can you apply integration by substitution techniques and get to where you want. So actually, the answers I'm going to give are going to be sort of powers of trig functions, sine or cos. So, and they might be quite high powers. What I'm not going to do is then go on to try and make them into sort of combinations of terms using double angle formulas. I'm not going to do that in this video. You may be asked to do it in certain instances. You may be asked to give your answer in a certain form. For this, I'm just testing, can you use integration by substitution to make things easier? So I'm looking at this, and then I'm looking for a u. So basically, you've got one thing times another. It's a messy old thing that you can't integrate straight away. So you need to select a u that's going to make one of these disappear. So if I was to select, let u equal cos x, well, you know, when you differentiate cos x, it's going to differentiate to sine x, and then when we do the rearrangement for dx, you're going to have like a sine x in the denominator, which is going to help us to get rid of that. So that's what we're going to do. So du by dx equals minus sine x, du equals minus sine x dx, which means that dx equals du divided by minus sine x. So then we're going to rewrite the integral if this was the original integral I. So now I equals, well, it's the integral of cos cubed x times the integral of, well, it was cos cubed x, so that was u cubed times sine x, and dx becomes du by minus sine x, du by minus sine x. So if you look at the sine x and the other sine x, so we can go 1, 1 there, and you've just got this negative to deal with, so that equals minus the integral of u cubed du. So as I said, I know this is cos cubed and I could potentially do a lot of work on this. I'm not going to. So I'm just going to use the polynomial rule, and I'm going to add 1 to the power, divide by new power. So it equals minus u4 over 4 plus c equals minus 1/4 of cos to the power 4x plus c. Now, I'm going to leave this as my final answer, but just to let you know what I mean. So say you wanted this in a reduced power form, the way you would start that, well, you would say equals minus 1/4, and that cos 4x could kind of be written as cos squared x squared, something like that, plus c. And then you could use this identity that hopefully you know, that cos 2x equals 2 cos squared x minus 1, and go from there. So make cos squared x the subject and get something in terms of a double angle, deal with it, you might get another one, and see where you can get to. It's going to take a long time. I'm not going to do it for this particular video. I'm just interested, can you use zero substitutions to reduce your initial integral to something a lot more manageable?